So we're going to talk a little more about functions, and one of the things in this section we're going to talk about are the domains of functions, and specifically some of the things that make a difference. So we have this chart here, and it's number of births and deaths in the United States. Gold is births, red is deaths, and kind of some weird things. This number over here is in thousands. So when they're saying right here 200,000, well, no, it's 2,000 thousandths. 2,000 thousandths. I can't even say it right. It's this number, but then you have to put that in terms of thousands, so it looks like that. So it's really 2 million. Now, why they went that way, I'm not sure. I think I would have gone 2, 2.3, 2.6, like that maybe, and put it in millions, but they didn't. Okay, so that's how to read that part. Then down here along the x-axis, it's the year. So we have the year 2000, 2002, 2004, 2006, so on and so forth. Okay, here is the model for births, and here's the model for deaths. Okay, so these are going to model these numbers that we have, the data, okay? Well, one thing on the x values, we're saying x is the years after 2000. So when we're saying 2000 right here, then x is equal to 2. And then when we're saying it's, 0. And then when we're saying 2002, x is equal to 2. And then here, x is equal to 4. And so on and so forth up to the year 2016, where x is equal to 16. Okay? So when we're talking about the domain, that's important. Now, we're getting this data then every 2 years is what we're getting. Okay, so the domain for our functions, the domain for both of them is 0, 2, 4, 6, on up to 16. And that would be the domain for the births, and it's also the domain for the deaths, because that's how our chart is working. Okay, so we don't have the domain for all real numbers between 0 and 16. We only have it for specific years. 0, 2, 4, 6, 8. Okay, so you have it for 2000, 2002, 2004. But remember, x is the number of years after 2000. Okay, so those are our domains. If I wanted to find the number of births, according to the model, when x is 2, so in 2002, I would plug that into the model for births. Oops, that's a 2. And I'm not going to do this, but you could put that all in a calculator and then it would approximate the number of births in 2002. Okay. And you could do the same thing for deaths. Now, when we're talking about domain, there are 2 things we have to watch out for. First of all, if we have a function like this, we cannot divide by 0. Divide by 0. So when does x minus 3 equal 0? When x equals 3, right? Okay, that's what we cannot have. Cannot have x being 3. So when we list the domain, we have to exclude that. We have to say the domain is from negative infinity to 3. Don't include the 3. And then from 3 to infinity. That's how you write it in interval notation. So we have like an excluded value. You can have any real number you want for this function right here, except you can't have 3, because we're not going to let you divide by 0. Okay? So that's one thing you have to caution on. Make sure your domain is excluding any values that would make the denominator 0. Okay. The other thing we watch out for is if I have, let's say, g of x is equal to the square root of x plus 5. Well, when I have an even root, this argument inside here, that has to be greater than or equal to 0. Okay? We can't take the square root of a negative number. It won't be real. So when I want to know about the domain for this function, for g of x, I have to say, well, x plus 5 has to be greater than or equal to 0. And then I can solve that. It's an inequality. So then when I want to write the interval notation, I need all the numbers that are greater than or equal to negative 5. So the domain would be bracket negative 5 to infinity. And it would look like that for the domain. Okay? So there are two things we have to be careful of. Can't divide by 0. Can't take the square root of a negative number. Okay? We'll do more work with this, but that's what we're going to be working on in this section is identifying domains. Some of what we're working on in this section. Okay.